I'm gonna record it and then let's see if it, I don't know if it's actually recording me, but whatever. All right, so just real quick, let's see here, let me share my screen. Okay, number one right here. Again, no, it's not a function right here because there's two of the same x values. Remember, for each x value, there's only one y value, and the number 10 has two y values. This second one is a function because all the numbers are different: 0, 3, 9, 12, and 15. Letter B, it is a function. If you graph a parabola, right, and use a vertical line test, notice that it only hits a parabola at one time. Letter D, it is not a function because this is a parabola to the side, and you do the vertical line test, it hits it twice. But Gio mentioned that if you go x is equal to y squared and you square root both sides, you get y is equal to the radical x. If you do it that way, and radical x is this graph right here, if you do it that way, technically it is a function there. Okay, letter D, notice that vertical line test, it hits the graph 3 times. Remember, if it hits it twice, if the vertical line hits the graph twice, it is not a function. Okay, number 2. All right, name 6 different parent functions and roughly draw each function. Okay, so we have the quadratic, right? And that's a parabola. Okay, we have cubic. That is something like this, where you go that. Okay, we have the absolute value, where it's kind of like a V, right? We have the radical, which looks something like this. What other ones do we have? Do we have step functions? Thank you. And these are just pretty much just little stairs. You just do this. Okay. And we have the exponential function. All right. You can do linear too. The exponential function, we didn't really go over that one too much.
What about square root?
The radical, we did that one already. Exponential function is this. Okay. And square root is here, radical. Okay. I think that's it, right? These was the ones that we went over. That's right. Okay, so linear is this, right? That's linear. And then reciprocal function. Reciprocal, we'll go over that a lot more during when we graph rational expressions, but it's this. Okay, cool. All right, any questions on that? Not too bad. All right. Number 3 here. Find the domain of the following functions. Remember, if it's a denominator, right, it can't be 0. So for letter A, all real numbers except 0, t equaling 0. Okay, because if you make t equal to 0, it's undefined, right? Letter B, all real numbers except what? S can't equal 4. Good. Right? Because if you plug in 4 for S, what happens to the denominator? It's 0, so it's undefined. Okay, so you can't do that. All right? Letter C, all real. Actually, you have to do what? This is X is greater than or equal to 5, right? Because any number less than 5, if you plug in 4, 3, 2, 1, 0, this is going to result in a negative radical, and you don't want a negative radical, or you don't want a negative inside the radical, right? Okay, so X has to be greater or equal to 5. Cool. All right. Okay, so number 4, remember we went over this, the other day with your, step function worksheet, but remember that this two is what the letter A is the, what? Horizontal, vertical, stretch or shrink. So it's a horizontal shrink. And this one is the vertical what? Stretch. All right. Are we good? All right. So we have the 2x inside. All right. And you may want to put a table of values. All right. For this x and y. Right. If I plug in again, like 1.1, 1.3, 1.5, 1.8. Yeah, and again, you don't have to use units. I mean, I know the graph is kind of small, but like you could do every 2 equals 1, like 1, 2, it might be helpful, 3, 4, 5. If I plug in 1.1 into this, this will be, if I plug in 1.1 in times 2, so 2 times 1.1, that's what? 2.2, round down is 2, right? If I plug in 2 times 1.3, what happens? This is 2, the 2.6, round down would be 2. What happens if I do 1.5?
It equals 3.
3, good. And this will be 3 until, up until 2, right? So at 1.1 and 2 would be like right here, right? Actually, let's do this here. Here's 1, here's 2. I'll skip on this one, 2, 3, 4. So let me erase this. And let me go from 1 to 1.5 will be at 2. And then from 1.5 to 2 will be at 3. Right? And then from 2.2 to 2.5, that's what? 4. And then from 2.5 to 3, it's 5. It looks something like this. Okay, like remember it's a horizontal shrink, so remember you're only on your tippy toes when you're going up the stairs. Cool. All right, and then the vertical stretch, this is what? Y is equal to 2 on the outside and then x. All right, what happens here? You guys get this one. So let's do a table of values. Y is equal to 2 and then step function x and y. So let's say it's 1.1, 1.3, 1.5, 1.7. And let's go 2.1. Let's maybe go out a little bit further out, 2.3, 2.5. 2 times, let's just do it, 2 times 1.1. Step function of 1.1 is what? 1. 1 times 2?
Yeah.
2. So the y value is 2. So here's 1, 2, 3, 4, and 5. So this would be at 2. So 1.1. And this is all going to be 2, right? So from 1 to 2, it's going to be at 2. So here's 1, here's 2. So let's do this here. Okay. What about at 2? The step function of 2.1 is what? 2. 2 times 2? 4. So all these values from 2 to 3 is going to be at 4. And then from 3 to 4 is going to be at 6. So on and so forth. So you're just going to, yeah. 0 to 1. Hold on a second. This is what? Sorry, this is wrong. This is what, this is here. Yeah. You know, it should be a little bit higher. Okay. Cool. All right, so again, you're stretching out vertically by 2. All right. And also you could graph this on the decimals calculator. You're not gonna have the decimals calculator for the test, but just so you know. All right. All right, number 5. What's anybody get the answer for this?
It's missing squares.
Oh, dude.
Yeah.
Oh, which one?
I have to go bring the paper over here, but
Okay.
it's like 5 squares.
Oh, okay. All right, thanks, man. I'll look at it. What would the answer be for this one? Y is equal to what? Absolute value of x plus 5, right? And then what? Plus 2. Why is it plus 5? Because again, sorry, it should be minus 5. My bad. I know. I'm dyslexic sometimes. It's minus 5, sorry.
It's a pain to change.
I know.
Every human makes mistakes.
I know, geez.
What?
That's gonna.
All right.
Sorry, you're looking at one day.
All right, using the information, state the given, describe, right, state the equation describing the transformation. All right, anybody get this one?
Y is equal to 3.
Sorry, say again, Sadie?
Y equals in parentheses 3x minus 6, and then out of parentheses minus 1. Oh, yeah.
Cool. Are we there? Is it good? Yeah, so almost there, but this is 18, right? Okay, right?
So it's.
Y is equal to 3x minus 18 cubed minus 5. You can also look at it this way.
I got it.
Cool?
Why is it?
Yeah.
Because remember the 3, you have to factor it out, right?
Oh,
So that, and then this is the, you have to factor out the 3, and that's why it's 18, right? So 3 times 6 is 18. So yeah, that should be it. Okay. All right. I think these are the toughest ones right here, number 6. Okay. So, all right. Letter B is what? Vertical stretch by 4. So Y is equal to, anybody get this one?
I don't know how to say it.
4 absolute value.
But it's reflected across the x.
So it'll be negative 4. Good job. And then what? X plus 3. No, yeah, X plus 3 plus 5. That looks good. Okay. Reflected across the x-axis, that's a negative. Vertical stretch by 4, that's the 4 in front. Right? Shift left. Again, you have to be the opposite side and shift up by 5. Good job. Okay. All right. All right. Number 7. Sorry, there's 2. I didn't realize there's 2 equations on this one. This one and this one. Okay. All right.
We don't have this one.
That was the first one. It's just okay. Let's just do this one then. Good. Okay. So we'll eliminate this one. Yes. All right. So if I were you, I would graph the parent, which is y is equal to, and then I would graph the negative 2 radical x first. Okay, do that first and then do the shifts. Okay, because it makes it less complicated. It's less math this way. All right, so let's just plug in, and we know we're going to use positive numbers because why? Why would we use only positive numbers?
because it's negative.
Yeah, you don't want a negative inside the radical, so it's just size 0, 1, 2, 3, and you may want to just use perfect squares too. So like 1, 4, right, 9, because that'll make it a little bit easier too, right? You don't have to deal with fractions or decimals or anything like that. Okay, so these are all the x values. So y is equal to -2 to the square root of 0. That's 0, right? Y is equal to -2 times radical 1. Radical 1 is 1 times -2 be -2.
Didn't you have to subtract the 3 first?
So I'm only graphing the parent,
But like if.
and then you could shift it right 3 and up 2. You get what I'm saying? Right? By doing that, let's do this one first, okay? So y is equal to -2 radical 4. Radical 4 is 2. 2 times -2 is -4, right? And then y is equal to -2 times radical 9. Radical 9 is 3, -6. Okay, so 0, 0, 1, -2, 1, -2, 4, -4. So 1, 2, 3, 4, -4 right here. And then 9, -6. So 5, 6, 7, 8, 9. And then this is 4, and then -6 right here. It looks something like this. Okay, but we're not done. Remember, we're just doing that. This is the parent. Okay. All right. So Kennedy asked, like, should we what do we do with the 3 and the 2? So what do you do with the 3 and the 2? You go. Let's do the. Yeah, you can do that. But I would go right 3 first, and then up 2. Okay, so right 3. Right. 1, 2, 3, and then up 2. So you're gonna be doing the same thing, but just shift it up. And if you just do this, like if you just kind of draw the sketch from there, that's fine. Okay. That's the whole point of this. The whole point is for you guys not to do the table, right? You guys rarely want to do the table because the table takes a long time, right? So let's make it let's make that table as easy as possible, right? And so we don't have to do the 3 and all that stuff. We could just shift it. Cool. All right. All right, taxi fares from Castaic to Los Angeles are described as follows. We did this the other day. All right. Again, I may go in increments of like 2, whatever, but yeah, maybe increments of 2. So this is like 2, 4, 6. Is that harder? That might be harder, huh? So maybe let's do it. Let's skip count. So
Yeah, basically.
let's do 1, 2, 3, 4, 5. I think we're gonna run out of room.
Yeah, you can run.
Okay, but I mean, I'll just do it from there. All right, so 5 for the first mile. Let's say this is 1. It'll be $5, right? Right, and then what? Between the mile after, what happens? It goes to what? 650, right? So 650 will be like right here, right? You just put 650 right here. And then 3 would be what? $8, right? Right? And then what? 4 would be $9.50. And then 5 would be $11. Something like that would be good. Okay. If you guys like start with 5 here, that's fine. Just do that and then just label the numbers differently, like 950. You know, you could do it that way too. Okay. But as long as you just show me the work, that's fine. All right. Write the piecewise function, right? Between 0 and 5 miles, right? Y is equal to, and I don't want to do the bracket, so I shouldn't have done the bracket. I should do like this. So I have 5. What's the interval going to be? 0, 1, right? At 650, it's going to be what? 1, 2, right? At $8, it's going to be what? 3 to 4. And then 950 would be 4 to 5. Okay. Also, maybe put the parentheses You're supposed to put parentheses on here, right? So,
Yeah, that.
so you could put the parentheses. I don't mind if you guys put the parentheses on the right or the left. Like if you do it here, if you do it like this. Or if you do it like this. And then do the parentheses. Either or in this situation is fine. Okay? Not too bad? We good? All right. Okay, I'll give you guys a break, but